Hello, students. We are jumping into a couple additional homework questions that came in pretty late, but hey, that's how it goes sometimes. So let me jump in and see if I can't get some white space. There we go. They did change the toolbar in Zoom, so it just took me a second. So questions were about 25 and 27. All right, so there we go, 25 and 27. And let's jump into those. And let's see here. So we have 5, 4 base B plus 4, 5 base B equals 1, 3, 2 base B. So when you look at this, think about the B is just your base. The B is your base. So maybe it's groups of 7, maybe it's groups of 6, maybe it's groups of 8. It can't be groups any smaller than that because there's a symbol for 5 and a symbol for 4. So the smallest it could be is a base 6, but let's check. So that means I have 5 groups of B's plus 4 ones. That's the first numeral. The next one is 4 groups of B plus 5 ones. And that is going to equal 1 group of B squared. That's the next digit over, plus 3 B's plus 2. Okay. So let's combine all of our like terms. So on one side, I have 9 B's plus 9 equals B squared plus 3B plus 2. So we got a couple options here. You do have a couple options. You could bring everything to one side and solve this with like the quadratic formula would be a good tool to use here. That's completely up to you if you want to use that tool. What else could you use? Let's get all the B's to one side. Let's show an alternative here. So if I got rid of 9 B's on both sides, subtract 9 B's from both sides, then that's going to leave me with, let's get rid of the 2 as well. So let's bring the 2 to the other side. So let's do a -2 and a -2. Okay, so that leaves me with a 7 on this side is equal to B squared minus 6B. And then you can just factor the right-hand side. 7 is equal to B times B minus 6. Okay, and now you really could kind of, I guess, just test a few numbers to see what number would I put in for B to make this equal to 7. And oftentimes, like I'll start with the smallest one. I know it can't be 6 anymore. 6 is out because 6 minus 6 would be 0. So I know it can't be 6. I'll try 7. So plug in 7 here for B. So that'd be 7 times 7 minus 6, which is 1. So 7 times 1 is 7. So at the end of the day, I could say that B is equal to 7. If you don't want to do that, like I said, you could factor. So B squared minus 6B minus 7 would be equal to 0. And you could factor this into B minus 7 and B plus 1 would be your factoring. And at the end of that, you would say that B is equal to 7 from the left-hand side, or B is equal to -1. And it can't be a base of -1. That wouldn't that wouldn't make any sense. So you'd also get the same, so B is equal to 7. So that's how you could check that numeral there if you wanted to. And you can go back up and test it. You can plug in, 7 times 5. 7 groups of 5 would be 35 plus 4. That'd be 39. Plus, and the next one is 7 groups of 4. So 28 plus 5, which is 33. And that has to equal, let's see here, B, so 7 squared, so that's 49, plus 3 groups of 7, which is 21, plus 2. And so you can check to see that actually does match up, and it does. And you could see that even without kind of doing all the additions. If you grabbed, let's see here. So there's a 39 here. Oops, still in white. There's a 39 here and a 49 here. So take 10 from this and make that a 49. That leaves you with 23 for the second number, and 21 plus 2 is 23. So you can tell that it's equal. You don't even have to know what number it is equal to. Right. Okay, so that takes care of that one. And similar for the next one, very similar. Let me throw some white space and some more white space here. So again, now it's asking you to do the same thing, but now it's asking you to find the digit B and kind of tell what it represents. So let's do kind of the similar piece. So on the left-hand side, I have 4 is my base, and B is the number of groups of 4. So what I have is I have 4B plus 3, and that's supposed to equal 3 groups of 10 plus 1, which would be just 31. And then, yeah, you can go through and do the typical algebra techniques, kind of get everything onto one side, and you get 4B equals 28, and then B is equal to 7. So that's how you could roll through and say, oh, that's 7. Problem is, and that is a problem, because this is a base 4 numeral, and the digit 7 does not exist. So it says find the digit B if possible. So I'd have to say in this case, even though I found the digit B that would work, numerically, it won't work in that system. So I would have to say for part A, this is not possible. I can't do it. For part B, this is a 1, 5, 3, 4 base 6. Okay, so that looks kind of complicated, but just write down your place values. 1, 6, 6 squared, and 6 cubed. So I have 1 times 6 cubed plus 5 times 6 squared plus 3 times 6 plus 4. Okay, that's on one side. On the other side, I have 1 times 12 squared plus 12B plus 2. And so those are equal. And let me straighten that out a little bit. There we go. And so now this is just a grab your calculator situation. Grab your calculator. 12 squared is 144, for example. 6 cubed is a different number. 6 squared, 6. So bring all of those over to one side. You'll have, on this side, you'll have just 12B equals some number that I'm going to make you do, because that's part of this. And then you could divide by 12 to get B by itself. And hopefully B actually works. Hopefully it fits in there. Remember, in base 12, you do have additional numerals. In base 12, you have a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you have a symbol for 10 and 11. For those, we would use T and E, 10 or 11. Okay. That wraps up 25 and 27. All right, off you go.